Hello guys, this is Kereka from Sri Venkateshwara College of Engineer Department of CSC. Today we'll discuss about algorithms. Introduction of algorithms. Algorithms are set of instructions that a computer follows to solve a problem or complete a task. They are like recipes for the computers, telling them exactly what steps to take to achieve a desired outcomes. Next, well, algorithms may seem complex, they're actually all around us in our daily lives. For the way we search for the informations of the internet of algorithms used for the social media platforms to show as contact algorithms play a crucial role in modern society. The diagram of the algorithms first input and algorithms and output. Next, types of algorithm. There are several types of algorithms, including sorting, searching, and optimization algorithms. Sorting algorithms are used to arrange data in a specific order, such as alphabetically or numerically order. Example, salting algorithm, including bubble salt, incitation salt, and quick salt. Searching algorithms, on the other hand, are used to find a specific them within a collections of the data. Binary search and linear search are the two types of the searching algorithms. Lastly, optimization algorithms are used to find the best possible solution to problem by optimizing a particular parameter. Example of optimization algorithms include granted, descent, and the stimulated analyzing. Next, working of the algorithms. Here the workings of the algorithm, how to works. Algorithm consists of the sequences of steps that must be followed in order to reach the desired outcome. The first step is executing an algorithm is to identify the problem that needs to be solved. Once the problem has been identified, the next step is to develop a plan for solving it. This plan is known as the algorithm. Next, the algorithms must be broken down into smaller steps, each of which can be executed by a computer. These steps are there translated into a programming language such as Java or Python, the compiler into machine code that can be executed by the computer. The execution of the algorithms involves following these in order until the desired outcomes achieved. This is called the working of the algorithm. Next, properties of algorithm. Well defined algorithms must have the precise defined steps, meaning there should be no ability in which each step entails. The instructions should be clear and understandable. Next, second one is finiteness. Algorithm should eventually terminate after a finite number of the steps. They should not run identically or result in an infinite loop. Next, definiteness. Each step of the algorithms must be precise and the unablases specified. It should not have the multiple interpretation. Correctness. An algorithm is a correct if produced the correct outcome for the possible valid inputs. It should solve the problems was designed for the accurately. Efficiency. Algorithm should be designed to perform the task effectively. Utilization resources, time, and the memory. Effectively, the effectively of algorithms is often analyzed in term of a time complexity of a space complexity. Adaptation. Some algorithms can adapt in a different inputs problems sizes, remaining efficiency and effective sensors. Scalability. The algorithm's perform should be detected when the applied to large instance. Next, properties of the algorithms. Types, time efficiency. Time efficiency, also known as the time complexity, it is a measure of how long an algorithm takes to solve a problem as a function of the input size. It quantities that amount of the time required by an algorithm to execute in a relation to the size of the input. It's important to design the algorithms with efficiency, time complexities to ensure they can handle large input size and execute within reasonable with time frames. However, the time complexity is not the only consideration when evaluation algorithms. Factors like memory usage ensures the implementations and problem specific requirements also play an role is selecting the most suitable algorithms for a particular task. Another properties of algorithm is space efficiency. Space efficiency, also known as the space complexity, is a measure of how much memory or storage an algorithm requires to solve a problem as a function of the input size. It quantities the amount of the memory used by an algorithm execute in a relation to the size of the input. When designing algorithms, it's essential to consider the both the time complexity and the space complexity has a trade-off often executing between them. So the algorithms might have the low time complexity but requires the significant amount of the memory. High space complexity will often the might they more memory efficient by taking the longer to execute. The choice of the most opportunities of algorithms depending upon the specific requirement of the problems available in comparison. Next, we'll discuss about the asymptote notification. Big O notification. Big O notation is a mathematical notation used to describe the upper bound of an algorithm's time complexity. It represents the worst case scenarios for the algorithm's running time as the input size approaches infinity. Here the graph diagram of the big O notation. Formula is Fn is equals to OZN. Next, big omega notation. Omega notation is used to describe the lower bound of the algorithm's time complexity. It is represented the best case sensors for an algorithm's running time. The graph, the formula Fn is equals to big omega g of n. Next, theta notation. Theta notation is used to describe the tight bond of the algorithm's time complexity. It represented the range of the functions that have the both an upper and the lower bound, meaning that the functions grows at the same rate at the best and the worst case sensors. And formula is the Fn is equals to theta g of n. Next, applications of the algorithm. Search engines algorithms are used to index, rank, and retrieve, evaluate information from the vast amount of the data, enabling the search engines to provide the evaluate search results to users. Next, sorting. Sorting algorithms or arranged data in a specific order that they are used in a database file systems and various applications where data needs to be organized from the efficient retrieval. Next, machine learning. What is machine learning? A wide range of the machine learning algorithms are used for a task such as a pattern recognition, classification, recursion, clustering, and the recommendation system. Next, natural language processing. Algorithms are used to process and analyze human language for the tasks such as text stimulation, certainty analyzing, and the language translation. Next, data mining. Algorithms are used to discover characterization and the trends to in a large database from the businessing intelligence and the discussing making. Next, robotics. Algorithms are used from a robot control planning and the negations of the automizes robots. Next, game development. Algorithms play and the crucial game development, including path finding and the detection, artificial intelligence from the game character, procedure, and the content generation. Thank you.